morning, viewers. This is Kasturi Day. Today, I'm going to discuss the remaining portion of the question answer series of the atomic structure according to ICSE syllabus class 8. Okay. So starting with the first question today, write the electronic distribution of the following atoms along with the name of electron shell. Okay. So we need to mention the electron shell, the name of the electron shell, and the number of atoms, the number of electrons which are present in the shells, in the respective cells of the atom. Okay, so first is sodium, which has a mass number of 23 and 11 as the atomic number, and the symbol is Na. So electronic configuration will be 11. Okay, number of electrons will be 11. So it will be divided in this way. In the first shell, that is K shell, there will be 2 electrons, 8 in the L shell, and this M shell will contain only 1. So 2 plus 8, that's 10, and the last one, that is 1. That means 11. So altogether, 11 electrons are present in sodium. Okay. Then we come to nitrogen. Nitrogen has a mass number of 14 and 7 as the atomic number. So electrons will be 7 in number, and they will be arranged in this way. K shell will contain 2 electrons, and the L shell will contain 5 electrons. Okay. So if you sum up these two shell electrons of these two cells, then you will get 7. Okay, then we come to silicon. Silicon has 29 and 14. 29 as the mass number and 14 as the atomic number. Okay, so the electrons will be 14, okay, in number, and that will be configured in this way. K will contain 2 electrons, L will contain 8 electrons, and the remaining electrons, that is 4 will be on the M shell. Okay, then sulfur has 32 and 16. 32 as the mass number and 16 is the atomic number. So electrons will be 16, and they will be arranged in this way. K will contain 2 electrons, L will contain 8 electrons, and the remaining 6 will be on the M shell. Okay, now how can you determine the number of neutrons in the nucleus of an atom from the knowledge of mass number and the atomic number? So we need to find out the number of neutrons. How can we determine it? So number of neutrons will be equal to mass number minus the atomic number. So if we know the mass number and if we know the atomic number, if we subtract the atomic number from the mass number, we will get the number of neutrons, because mass number is proton plus neutrons, and atomic number is the number of neutrons and number of protons or number of electrons. Okay. So the number of neutrons will be mass number minus atomic number. Next question, draw geometric representation of the following atoms showing clearly the number of protons, the number of neutrons, and the number of electrons in various shells. Calcium will contain 40 as the mass number and 20 as the atomic number. So that will be represented as protons will be then 20, and electrons will be also 20, and neutrons will be 40 minus 20, that will be equal to 20, and electronic configuration will be 2882. Okay, so the first shell, K shell, will contain 2 electrons, L shell will contain 8, M shell will contain 8 again, and the last shell, that is N shell, that will contain 2 electrons. So this is the configuration of the calcium, and this is the diagrammatic representation. Next we come to argon, which has 40 as the mass number and 18 as the atomic number. Now argon, the protons present on the argon is 18, because atomic number is 18, and so electrons will also be 18, and the neutron will be 40 minus 18, that will be 22. Okay, so we see that the electronic configuration in this element is 2, 8, and 8. That means it's a noble gas. Okay, so the electronic configuration will be, diagrammatic representation will be like this. 2 on the first shell, second shell will also contain 2, and the third shell, the last valence shell, that will also contain 8 electrons. That is, it serves the, it will prove the octet rule. Okay, so it has completed the octet and therefore it's an argon gas. Okay, I mean it's a noble gas. Okay, next we come to chlorine, which is 35 as the atomic number, mass number, and 17 is the atomic number. So the protons in it is 17, electrons is also 17, and neutron is 35 minus 17, that is 18. The electronic configuration is 2, 8, and 7. So it will be arranged in this way. See the diagrammatic representation. The first shell, K shell, will contain 2. The L shell will contain 8. And the last shell, that is M shell, the valence shell, that will contain 7 electrons. Okay. Now we define the isotope giving examples. State 3 properties of isotopes. We know that isotopes are atoms of the same element. Iso means similar. Okay. So isotopes means same elements having the atoms which has the same atomic number but different mass number. This is due to the fact that it has the number of neutrons which is more. The difference between the two atoms of the same element is because of the number of neutrons. One has less and the other has more neutrons. That is why the mass number differs, but atomic number remains the same. That is, their electrons, number of electrons or number of protons, that is same. Okay. Like, see, for example, carbon, which is 12, 13, and 14. Okay. The mass numbers. So first one, carbon 12, it has the mass number 12 and atomic number as 6. Second, carbon 13, having the mass number 13 and 6 as the atomic number. Then 14 carbon atom has 14 as the mass number and 6 is the atomic number. So atomic numbers are same. In case of chlorine also 35 and 37, chlorine 35, chlorine 37. So chlorine 35 has the mass number of 35 and atomic number 17. Whereas chlorine 37 has the 37 as the mass number and 17 as the atomic number. See, the mass number differs due to the presence of more neutrons, more and less neutrons. That is, differs due to the number of neutrons. Next, we come to the properties of isotopes. Now, the isotope of an element have the same chemical properties as they all have the same atomic number. As their atomic numbers are the same, therefore their chemical properties are also same. Okay. All the isotopes have same electronic configuration. So they all have the same atomic number. Okay, their electronic number is same, electronic configuration is same, and because their atomic number is same. So same atomic number, due to the same atomic number, their chemical properties are same, their electronic configurations are the same. But due to the difference in their mass numbers, isotope differs in their physical properties like density, boiling point, melting point, etc. That differs due to the presence of different mass numbers. Okay, that's why their physical properties differ. Next, we come to draw geometric diagrams of the 3 isotopes of hydrogen. Protium, deuterium, and tritium are the 3 isotopes of hydrogen. First, in the first case, see their electronic configuration is same because their atomic number is same. Atomic number is 1 in all the 3 cases. But their mass number, first one, protium has 1 as the mass number, deuterium has 2 as the mass number, tritium has 3 as the mass number. Because the neutrons in the first case, protium is 1, second case neutron is 2, and the first case neutron is 0, second case neutron is 1, and the third case neutron is 2. Okay. So next will be state 3 ways by which atomic theory of structure of matter differs from Dalton's atomic theory of matter. See, Dalton has given us an atomic theory which differs from the modern atomic theories. Why is it so? Atom, according to Dalton, he told that atom is not divisible, no longer divisible. I mean, sorry. Yes, he told that atoms cannot be divided further. But according to the modern theory, atoms can be divided into subatomic parts like electrons, protons, and neutrons. Second point, atoms of the same element are not alike in all respects. Okay, he told that atoms are all alike. Single element, the atoms of a single element, they are all alike. But we see in the, due to the presence of isotopes, the discovery of isotopes has proved that, excuse me, that atoms of the same element can be different. Excuse me. So atoms always do not combine in small whole numbers. He told that atoms combine in small whole numbers, but no, atoms do not combine always in small whole numbers. For example, the molecules of stearic acid has a formula of C17H35COOH, which is not a small whole number. So atoms are always do not combine in small whole numbers. They atoms of a single element also can be different. Okay, then atoms can be divided into subatomic parts like electrons, protons, and neutrons, but atom is still a smallest unit of matter which takes part in the chemical reaction. Okay, it is still a smallest unit of mass, smallest unit of matter which takes part in the chemical reactions. So these are the three ways you can say by which atomic theory structure of matter differs from Dalton's atomic theory. Okay, next we come to the state 5 assumptions of Dalton's atomic theory. He told that the matter consists of very small and indivisible particles of called atoms. I told you that he told according to him that atoms cannot be divided. He's telling that atom consists of very small and indivisible particles called atoms. Then atoms can neither be created nor destroyed. Okay, the atoms of an element are identical in all respects. Atoms of an element, they are all similar. But this has been proved wrong by the discovery of isotopes. So he told that their size, their mass, their density, the chemical properties, all are similar to that of another atom of the same element. But it can differ. These all properties differ if we compare one atom of one element and the one atom of another element. That is two elements. If the elements differ, their characteristics will also differ. This has been told by Dalton. Okay, but we see that atoms of the same element also differs. This has been proved by the discovery of isotopes. Now, atoms of the element, they combine in small whole numbers, he told, that molecules to form the molecules of that element, but not always. This has been proved by the modern theories. Then atom of an element combined with the atoms of another element is a simple whole number ratio to form molecules of compounds. Again, he said that they are combine in small whole numbers ratios to form the molecules of compound. That is not always possible. Okay. Now, atoms are the smallest unit of matter that take part in the chemical reaction during which only rearrangement of atoms takes place. Okay. This is also stayed correct according to the modern theory also. Still the smallest unit of matter, which is taking part in the chemical reactions during which only rearrangement of the atoms takes place. Okay. Next we come to name the nucleons present within the nucleus of an atom and the state, the mass and charge. Nucleons which are present within the nucleus are protons and neutrons. Okay, so protons and neutrons combined together form nucleons. Okay, so protons has positive charge, whereas neutrons have zero charge, no charge at all, neutral charge. Then protons have 1.6 into 10 to the power minus 24 grams as the mass. Neutrons also have 1.6 into 10 to the power minus 24 grams. Okay, this is the mass, that is the mass of the protons and neutrons. They are similar in number. Okay, I mean their mass is similar, but their charge differs. Proton has positive charge, whereas neutrons have neutral charge. Then what are bound electrons and what are valence electrons? Bound electrons are those which remain in a shell, in the shells which are close to the nucleus. So the shells which are close to the nucleus, the electrons which are present on those shells, those are known as bound electrons because they're held strongly by the electric pull of the nucleus. Okay, the nucleus has a strong electrical force, okay, by which the electrons are held strongly towards itself on the shells. Okay, so the closer the electrons are towards the nucleus, the more force of this electric force will increase. Okay, so those electrons which are near to the nucleus, in the shells which are closer to the nucleus, those electrons will be known as bound electrons. And the valence electrons are those which remain in the outermost shell that experience very small nuclear force, because the distance between the nucleus and them and the electrons is greater. Okay, so the force is much less, and the outermost shell, the electrons which are present on the outermost shell, those are known as valence electrons. Okay, now how is an atom electrically stable? Now, an atom is electrically stable because it has equal number of protons and equal number of electrons in the ground state, in the whatever state it is, okay, in the neutral state, ground state. It is electrically neutral because it has the same number of protons and the same number of electrons. Whatever the number of protons it has, the same number of electrons it will have, and whatever charge, positive charge it is having, that same number of negative charge will be there on the electrons. That makes the atom electrically neutral, electrically stable. Okay. So this is the end of this atomic structure, and this is the end of the science syllabus of this class 8 according to ICSE syllabus class 8. Okay. So I'll start in my next video with class 9. First, I'll start with biology. Okay. So stay tuned and do subscribe to get the notification of my next video. And if you have any doubt on any of these subjects, physics, chemistry, or biology, please do write in the comment box. Do share with your friends so that they can also be benefited from these videos. And you can also refer to my email ID, kasturi74@gmail.com. Okay, it is KASTURI kasturi74@gmail.com. Okay, so please refer to my email ID if you have lots of doubts, or if you have small doubts, you can write in the comment box also. I'll reply to you as soon as possible. Okay, so thank you for watching and have a good day.